Hello everyone, in the next video I'm going to talk about transformation of coordinates. That's very important in position astronomy. So we're going to talk about the transformation between rectangular coordinates and type of spherical coordinates. In a moment you're going to see why I say as type of spherical coordinates. As a review, what we mean by rectangular coordinates is that we can indicate a point by the distance x, by the distance y, and by the distance z, and we travel in each direction, so we have a vector like this. So let's suppose that we have this vector in a sphere. How we can indicate the position of this point? That here is normally indicated by this vector. So what we do is the following. Imagine that we have our sphere here. So what we do is we move a direction phi. We move here a direction phi, and we have, for example, our point here, and we also move a direction theta here and a direction r. So with this we can indicate every point in a sphere, and if we vary the r, we can indicate any point in the plane. So they are equivalent. They must be an equivalent between these two forms to express the position of a coordinate. So the position of a point, excuse me. So let us see what is that equivalation. So what we're going to do is that we're going to find that relationship seeing the drawings. So we have here our x, here y, and here z, and imagine that we have a sphere here, such that we can indicate a point here, and we are going to have a distance here and a distance here. So let's see that this is going to be r, and for that reason, in this triangle that I'm going to fill with blue, we are going to have that this distance, because it's a rect triangle, is going to be r sin of theta, and this distance in this another rect triangle that I'm going to fill with red is going to be this distance. This one is going to be r cosine of theta. In this way we can find the projection of this distance in the y direction that's going to correspond to the y movement or the y coordinate. That is going to be r cosine of theta times sine of v, because this is going to be v. In the other hand, this is going to be r cosine of theta times cosine of v. Where we haven't did anything rare. What we do is the projection of r times cosine of theta in the y plane and in the x plane, and we see that corresponds to the x and to the y in each case. So we have here a transformation that is that theta is going to be r times sine of theta, and y is going to be r times cosine of theta times sine of z, and x is r times cosine of theta times cosine of v. So that's the relationship that we have to transform from the circular the spherical coordinates to the rectangular coordinates. So now let us analyze the other case, that we have here the rectangular coordinates and we want to get the spherical coordinates. So let us see that the distance r is going to be the coordinate r. So from here we can easily get that this triangle have a magnitude of x to the 2 minus y to the 2 and the square of this, because of Pythagoras theorem, and we have that here is theta. So from here we can see that the magnitude of r is going to be x to the 2 plus y to the 2 plus theta to the 2 and the square of this. That's going to be the magnitude of r. Now in the same way we can find this angle easily with the tangent, because we can say that the tangent of theta of z is going to be x over y. You need to take into account in what is your quadrant to know the exact angle, because the calculators don't work for every case because they are defined in an interval. Now let us know that we can find also easily was the angle theta here. We can find this angle theta here because we also can say that the tangent of theta is going to be theta over x to the 2 plus y to the 2 and the square of this. So from here we only need to take arc tangent, or in both cases to know what are going to be theta and what v is going to be. So in this way we can find the spherical coordinates from the rectangular coordinates. So that's what we have. So in the next video I'm going to explain how from here get the relationship of sides and angles, relationship between sides and angles in a spherical triangle. So see you later.